record so you've got it to go. Okay, so we've got this first question, says A and B are drawn on the grid. Describe fully transformation which maps A onto B. That's important. Which direction it goes to. Okay? So A onto B means A is the object, B is the image. Alright, so it goes from A to B. So, what do you notice about B? It's bigger. Therefore, the single transformation means we've only got one thing. It's getting bigger, so the only thing that does that is an enlargement. That would be one of the marks. Okay? The other things we have to say is how much bigger. So we look at a scale factor of 2, because one side was 2, it's now 4. So we've got a scale factor of 2. And then we need what's called the centre of enlargement. You all know how to find the centre of enlargement? Well, what you do is you take your ruler, you take a point on the image, you take a point on the object, and you keep drawing, okay? And then you do the same through another point, and they will, if you do it nicely, meet at a point. And we can check with this point as well, and they all meet. So that's my centre of enlargement, which just happens to be at 5, 6. Don't get it the wrong way around. They don't have any sympathy, right? So it's about 5, 6. So that would be your centre of enlargement. Okay. We don't need to write a full paragraph or anything. They are the marks. 1, 2, 3 marks. Any questions about that?
What's the second part?
This scale factor of 2. Okay. Now you can put scale factor 2, you can just put times 2, whatever you like, but as long as you've got that, then that's fine. What would happen if my scale factor was a negative number? No. What would happen if my scale factor was a fraction? It gets smaller. So if I times by a half, so if I was going the other way from B to A, the scale factor of a half, 0.5. Yeah. If it was a negative scale factor, right, and A was the object, B would actually end up here, the other side of the centre of enlargement. So you count back, you get 2 to that point. Instead of going 4 in the same direction for times 2, if it was times negative 2 to that direction, you'd go 4 the other direction. So this triangle would actually be up here somewhere if it's a negative. Do you remember seeing that before? No? So you can tell if it's an enlarged shape and it's kind of looks like it's been rotated, it's not an enlargement and a rotation, it's an enlargement with a negative scale factor. Okay? Maybe we'll find one of those on the sheet. Reflect the triangle. Everyone's all right with this, yeah? X equals 4. You should draw your line in. That means you get it right. And then your reflection would be like that. Okay. Okay, any other questions you wanted to, you've already identified? No? Let's have a look at this. Oh, this is that one. Okay, what about the rotation? How do you go about doing it? Because if we were doing it pen and paper like you are, I might offer you some tracing paper, but you're on a computer screen. So how can we go about doing 90 degrees centre 0? Do you know what that means? Well, what I would do, go on.
You basically want to put your finger on the 0 and
Yeah.
rotate it 90
It
degrees.
needs to rotate, which is good on pen and paper, but not so good on a computer screen. So what I tend to do is I look at an L shape, and I kind of go how far up and how far right, and if I rotate that L shape 90 degrees clockwise, it looks like that. Okay, and then I can relate my shape to that point. Alright, so that would then be up like that. So that's what it's going to look like when we go far enough. Alright. So that's one way to do it. I'm sure you've got other ways. Now, I've just got one tip here that you might want to write on your paper. Don't just count squares. Always, always, always look at the scale that you're given on the axis. Rotations tend to be alright, but sometimes with reflections, and even especially translations, people get used to counting squares, but it's not squares, it's measurements along the axis that you have to do. So just check what the axes say. Alright? Okay, so because we weren't very good at enlargement, how would we do this enlargement? What would you do? Yep.
You would, because you know your center is at spot to the left of the V,
Yeah.
you would draw a straight line going from the center to the top of the V triangle and keep going until it hooks up there. That's good. And then you know that the bottom of the second triangle has to be in line with the bottom of the V triangle because that line goes right there.
Yeah.
So you would multiply the 3 by 3 with 9, and so the top of your second triangle should be 7, 11.
Okay, so that's perfectly good, the ray lines. I do find sometimes people make mistakes because they don't lay their ruler properly. So another way just to make sure is the distance from that point, remember I said that L shapes, it's 2 across and 3 up. So you do that 3 times. So go 2 across, 3 up, 2 across, 3 up. Check I'm still on my line, all right. 2 across, 3 up. So that is my new point. Okay, and as you said, that's actually a distance of 9. Right? And now I know that this point has to be straight underneath it. This distance is 2, so it needs to be 6. So there's my new. So just be careful with the ray line version, because if you are careless with your ruler, it's very easy to go 1 square out and you get something wrong. So just double check by doing the 2, 3, 2, 3, 2, 3. Happens 3 times. If it's a scale factor of 3. Is there anything else anyone had a look at and thought, yeah, we could do with discussing it? Eon's cubes, the same sort of thing. Alright. How are you with those kind of reflections? Some people find those difficult. So what would be, if anyone were to give you a tip, those that know how to do it, what would be the tip that you would give to make sure this goes right? Betsy?
Well, I know you should, you can't really just fold your paper.
You could fold your paper, yeah, but like say you can't do it on a computer screen, yeah.
And also, what I did was I turned my paper sideways and I looked at how far each, like the corner of that triangle was away from the bottom.
Yeah, so a lot of people find it easier to put that if that line is vertical or horizontal rather than diagonal. But basically the rule is we have to go perpendicular to the mirror line, as if we were looking directly into the mirror. So this point must be the same distance perpendicular to the other side. So we don't get confused by the diagonals. So we go from this point is 1.5. So we go a half and 1. We kind of do the reverse. This point is 1, 2. So we go perpendicular 1, 2. And if I do it in points like that, rather than trying to draw the shape, I can now see here is my reflected shape. And that's so easy. Quite often people do it that way, and they'll end up with something like that, which is not correct. It's definitely, this is the correct version. So it's that going perpendicular. You can always check by drawing your lines, check they're all parallel. And if you've got one wrong, then your lines won't be parallel. Right, transformation. Are you alright? We talked transformations before, yeah? Okay.
You said for the questions, the scale factor.
Yeah.
It goes up and to the right of the original image. Does that, or the original object, does that mean it's negative?
No, it means, so for instance, I'm going to take this one. I'm just going to do an enlargement on this one. So not the question it's asking before. Let's do an enlargement using a negative scale factor, doing this shape. So if you can find this in your paper, let's actually do an enlargement, okay, about 0, 0, which is the origin, and let's do a scale factor of, I think I'll have to do -1. Focused? Good. Now, a scale factor of 1 on its own wouldn't be worth anything, right? There'd be no point doing a scale factor of 1. Why?
Because that's just multiplying it by 1.
And
the same.
it'd be the same shape in the same place. But a scale factor of -1 does something different. So my centre of enlargement, if I do times -1, that's going to be my centre of enlargement. And remember what I said, well, you said about the ray lines. So if I put my ray line between, I'm going to just put it all the way through, like that, so on. But you'll notice this time that the ray lines have gone the other side. So how I do a negative number, if it was -2, you just make it bigger. But what I would do, remember I said, to get this point, I go across 1, up 1. So I go right 1, up 1. So if I do -1, I'm going to go left 1, down 1. So it goes left. This point over here is right 4, up 1. So I'm going to go left 4, down 1. So it's there. All right. This point would be here. This point I didn't do, but it's going to be here, isn't it? All right. So that would be my shape. Now, you'll then notice that the shape is the same size because it's 1, but it's -1, which has looked like it has rotated it. Now, in this case, a scale factor of -1 is the same as a rotation, right? Rotation of how far? 180. But if I did a scale factor of -2, this would actually not be then the same, because what would happen is this point would then be further away, so it wouldn't be a proper rotation, and it'd be bigger. So if I did -2, this point would actually be here. I think we're running out of batteries. Maybe you can try it on your paper now. So if I tried to do -2, this point would now end up here. This point would end up somewhere over here. This point would end up over here, down here somewhere. So we get twice as big and a little bit further away. Alright? So it would not be a rotation that time. But that would be a negative, so it would end up in the other, it would end up the opposite side of the centre. So if my centre of enlargement was up here, the shape would actually then end up over there. If it was negative, it would end up this side if it was positive. Make sense?
How do you know how big the shape's going to be? Just by saying, still back with maybe 2.
Well, because the negative means it's the other side,
Yeah.
the 2 means it's going to be twice as big.
Oh,
Yeah? So every side will be twice what it was before. So it's, okay. Anything else you want to look at? What's this one? Anything else you've spoken? No? Okay.